Hello friends, here we have yet another interesting question. So let ABC be an acute angle triangle with AB is less than AC and an orthocenter H. We also have a circumcircle, that is a circle connecting all the vertices, and the orthocenter is the intersection of all the three altitudes of a triangle. And we let M be the midpoint of the minor arc BC of the circumcircle. We suppose that MH is equal to the radius of the circumcircle and need to show that angle BAC equals 60 degrees. Now let's see in the diagram. So here we have a triangle ABC and these are the x and y axis, and this is the coordinate 0, 0. For radius r, we have this coordinate as 0, r and this as 0, minus r. Now assuming that we name the coordinates, so for C we name it as b, c. For b we name it as minus b, c, since the midpoint M lies on the y-axis. So we make it such that the midpoint M lies on the y-axis, and then for A we have the points P, Q. But since A, B and C all lie on a circle, we have P square plus Q square equals B square plus C square equals R square. Now here we have an altitude, let's say A1, and we form a second altitude perpendicular to the line P and joining C, and we name this as A2. So A1 and A2 meet at the orthocenter H here. Now for A2 we have M A2 equals minus 1 by M AB. For MAB we have Q minus C by P plus B, and hence for MA2 we have P plus B by C minus Q. As the altitude A2 passes through B minus C, then we have equals to y minus C by x minus B. Now since for the point H which lies on both the altitudes, and for the altitude of A1 the equation already being x equals to P, then substituting x equals to P here we get P square minus B square equals C minus Q times y minus C. Now from here you may notice that P square minus B square equals C square minus Q square, which is equal to C minus Q times C plus Q. Now substituting this by C minus Q times C plus Q and cancelling this out, we get y equals to 2C plus Q. So for the point H we hence have the coordinates P, 2C plus Q. Now as we know the length MH, so we join M to H, then we have the length MH equal to the radius of the circumcircle, which is R. For length MH we have under root of P square plus 2C plus Q plus R whole square, and this equals to R. So R square equals P square plus 2C plus Q plus R whole square. Substituting R square by P square plus Q square, we get P square plus Q square equals P square plus 2C plus Q plus R whole square, and hence Q equals 2C plus Q plus R. We only take the positive values, or only the magnitudes, we ignore the signs, and this gives us R equals 2C just for the magnitudes, and hence C equals R by 2. Now for the point C, as we had here, for this point C sorry, for this point C, we had the coordinates b comma c. Now you may notice that we have the coordinates 0 comma 0 here. This value is r, and we found that the y coordinate c has a magnitude of r by 2. So this coordinate is r by 2. Now drawing that triangle independently, we have r and r by 2. As you may easily guess, as you may easily see, we have 30 degrees here, since sine 30 degree equals half. So sine inverse of half equals to 30 degree. Since this angle equals 30 degree, then we have this angle equal to 60 degree, and hence for the angle BC then subtends a total angle of 2 times 60 degree, as these two triangles are congruent. So because these sides are equal as we partitioned along the y-axis, and these angles are again equal, so for these two congruent triangles we have a total of 120 degrees subtended at the center. As the angle subtended at center is twice the angle subtended at any point on the circle, then we have angle BAC equals 60 degrees. Thank you. For more other interesting math courses, you may refer the links in the description below.